Assalamu alaikum everyone. Today we will start Numerical 2.4 Kinematics Chapter 2 Physics. A tennis ball is hit vertically upward with a velocity of 30 meters per second. It takes 3 seconds to reach the highest point. Calculate the maximum height reached by the ball and how long it will take to return to the ground. Now quickly enlist the given data. The initial velocity of the ball is given to us. Vi is equals to Vi is initial velocity. It is 30 meter per second. And ball took 3 seconds to reach the maximum height. We have to find the height, the maximum height, and we have to calculate the total time within which the ball returned back to the ground. The total time to return to ground. So now quickly understand the scenario. We have a tennis racket. And a ball was hit with the tennis racket vertically upward. Ball was moving with initial velocity is 30 meters per second. The ball reached to a maximum height where it rests. When the ball is at rest, its final velocity is 0 meter per second square. The ball reaches the maximum point within 3 seconds. We have to find this height that ball attained in 3 seconds. To calculate the height, we can use the equation of motions. So here we can use second equation of motion and the third equation of motion. The second equation of motion, S is equals to Vi multiplied by T into 1 over 2 AT square. And in third equation of motion, 2AS is equals to Vf square minus Vi square. And in both of these equations, S is unknown to us. Initial velocity is given to us, time is given, and acceleration A. In this type of problem, when the balls or anything is moving vertically upward or coming back downward, we use the gravitational acceleration G. Its value is 10 meters per second square. If the ball is coming downward toward the center of the earth, the value is positive. But if the ball is going in upward direction or any object is traveling away from the earth, the value of gravitational acceleration is negative 10 meter per second square. In this problem, the ball is moving upward, so we take G as a negative 10 meter per second square here. And in that kind of problem, the equation of motion is converted to the height problems. S is converted to H. S is distance, horizontal distance, H is the vertical distance, Vi is initial velocity, T is the time plus half, and A is an acceleration. But here in vertical upward and the downward problems, the gravitational acceleration involved, so A is converted to Gt square. Similarly, you can convert the third equation of motion as 2AH is equals to Vf square minus Vi square. Now let's calculate this height by using both equations. So with the help of second equation, we can want to calculate the H. We have initial velocity, that is 30 meters per second, multiplied with the time 3 seconds. The ball took 3 seconds to reach the maximum height point. Half minus 10 meters per second square into 3 seconds square. So it is 90 meter plus half of minus 90 meter. 90 meter plus 45 meter, sorry, this sign is negative, not positive, because this negative and this positive convert this to the negative. This is the 45 meter. The maximum height that ball attained in 3 seconds is 45 meter. Now with the help of third equation, the same answer will be appear, but we have to check it. So here you put the value of g, the gravitational acceleration, but in this case, okay, 10 meters per second square. H, the final velocity is 0 meters per second, and the initial velocity is 30 meters per second square. 0 meters per second minus 900 meters square per second square. So H minus 20 meters per second square. So H is equal to 900 meters square second square divided by minus 20 meter per second square. After a little bit mathematics, it is equals to the 45 meters. So both equations will give us the same answer. Both are easy to use, but I prefer you to use the second equation here, because the second part of this numerical, in which we want to calculate the time for which the ball returned to the ground, is calculated by using the second equation of motion, because in the third equation of motion is independent of time. So now we have to solve the second part of this numerical, in which we want to calculate the time that ball took to return back to the ground. Now the scenario was different. The ball was reached at the maximum height. This height is now the ball was reached the maximum height, and this height is 45 meter. The ball is at rest, means its velocity is 0 meters per second here, and it's coming back towards the ground. So how long it take to back to this to travel this 45 meter downward? We have the velocity, we have the s, and we know the ball is coming downward. As I told you, in the downward direction, the value of g is taken as positive 10 meters per second square. So now we will take g plus 10 meter per second. So using second equation of motion, and because in this problem, in this scenario, the scenario was different from the scenario when it was hit with the tennis racket. Now the ball reached at the maximum height. At the maximum height, this is your new reference. So with this new reference, the velocity at this point is known as initial velocity. So now initial velocity is 0, because ball is at the maximum height and is at a rest position at the 0 velocity. It's coming back under the influence of gravitational force with gravitational acceleration g. So h is equals to VIT plus half GT square. We know the height is 45 meters. The initial velocity is 0 meters per second, multiplied by the time that we have to calculate, half into 10 meters per second square into t square. Now 0 multiplied by t is 0 plus 5 meters per second square into t square, 45 meter. Now rearranging this equation, 45 meter divided by 5 meters per second, 9 seconds square. Now taking square root both the side, t is equals to 9s square under root is equals to 3 seconds. So ball took 3 seconds to return to the ground. But we have to find the total time that ball took to come back to the ground. So the ball took 3 seconds to reach the maximum height in the first part of our problem, and then it took 3 more seconds to come back to the ground. Total time that ball took during this whole journey is equals to 3 seconds plus 3 seconds, that is equals to 6 seconds. So that's all about this problem. If you understand this, like my video, share my video with your friends, and subscribe my channel. Thank you very much.